Hello and welcome to SudoKanard. Here is the Mathrax Sudoku that I published on my blog a few months ago. And so the special rule is that whenever you have an operation symbol with a number, it means that this number is the result of the operation applied on the two digits on the diagonal, and same for both diagonals. So the sum of those two digits is 6, same here. If the total is replaced by a question mark, it means that this total has to be determined. But here, the product of those two digits is the same as the product of those two digits. And an E means that all digits here around the E are evens. All four digits here are evens. And here, O means that they are odd. And that's it. And with that, the rules of Sudoku apply. So let's start. Here, the sum of two digits being equal to 6 means that they are 1 plus 5 or 2 plus 6. But this digit here has to be even. So this is 2 or 4, and so does this. And the other diagonal now is made of 1 and 5. And this even digit now can only be 6 or 8. Here we have all four even digits. Let's say this. Well, that's true for that as well, but the important part is that this column now has four even digits, and we must remain that here and there, those must be odd digits. The products that are equal to 6 are 1 times 6 or 2 times 3, but this is an even digit, so it's 2 or 6. And correspondingly, this must be 3 or 1, 2 times 3 or 6 times 1. So here, the product must be the same in both directions. Now let's imagine that this is 5. Then this will be some number that's a multiple of 5. So this must have a product multiple of 5. So this should be 5, and that's not possible. So this is 1, this is 5. And it means that this digit here is equal to this times that. So this must be an even digit, but we already knew that. And it means that, well, let's say this could be a 2, in which case this would be a 4. Or an 8. This is an even digit, so it's 4, 6, or 8, or 2, but 2 here would mean that this times that is 1 times 2, so that wouldn't be possible. So what are the options? This could be 2, and 2 times 2 equals 1 times 4. This could be 3, and 3 times 2 is 1 times 6. It could be a 4, but no, 4 wouldn't work, because if I try to put 4 here and 2 there, then I have no option for this. So this couldn't be a 4, but this can still be 8. No, it can't be 8. If I make this 8, then this has to be 2 and this has to be 4, and there's no value for this. So this can't be 8. It's 4 or 6. And now this can't be 4. If this were 4, then this wouldn't be 4 either, and this wouldn't be 6. So this is 2, this is 4, and we have a 2 and a 4, or a 3 and a 6. This is also an even digit. Well, I just pencil mark the 4 options. Now here, a sum of 5, so that's either 1 plus 4 or 2 plus 3, but this is not 2, so this is not 3. We know there's a 3 somewhere here, and there's a 2 somewhere here. But now those are odd digits, so this is 1, this is 2, this is 4, this is 3, and now this is 6, and this is 3. And this is neither 2 nor 6. and that's it. We have other odd digits here, so this is 5, 7, or 9. And we now know that the difference here is the same as the difference there. And knowing that this is one more than this must be one less than this. It has to be 4, 6, or 8. So the difference here could be 3, in which case this is 5 and this is 4, but 4 is forbidden, so that doesn't happen. We could have 2 and 9, difference of 7, and that would be 1 and 8. Or it could be 2 and 7 for difference of 5, and this would be 1 and 6. So this is 6, 7, or 8, 9. Product of 8. So this is either 1 times 8 or 2 times 4. But we know that 1 can't be here, and we have even digits here, so 1 can't be here either. So this is 1, this is 8, and the other diagonal is 2 times 4. This is now forced to be a 6, which makes this a 2. And this is now a 6. This is 4 or 8, and this is actually 8. The product must be the same, but if I try to make this a 3, then this has to be a 12, and that doesn't work. So that's a 1, that's a 3, and this is now a 4. So what's next? This 2 here makes this a 6. Now that's 8, that's 4, and that's 4. Here we have the same sum on both diagonals. And I'm not sure what to do with this information. This even digit can only be an 8. This is 2 or 4. We have a 2-4 pair here. Now the sum is the same on both diagonals. If I try to make this a 2, then this is a 4, and this has to be -1, which is not allowed. So this is 4, this is 2, that's 4, and for this clue to be true, this has to be a 3. And by Sudoku I get a 3 here. The remaining cells here have 4, 7, 9. Those must be odd, so this is 5, 7, or 9. This is 3, 5, 7, or 9. We've almost exhausted the clues, the Mathrax clues, I mean, but not quite. 6 is not here, so there's a 6 up there. By Sudoku I get a 6 here. Those can't be 3, so this is 3. 5, 7, 9 here. 7, 9 there. The remaining digits in the column, there must be an 8, so 8 is here. Those are 2 and 5. In this column, I still need 1, 7, and 9, but 1 is not down there. 7, 9, and 5 here. And 5 is here, so that's 3, 7, and 9. And here, 1, 7, and 9. So where do we look now? Here, that's 5, 7, and 9 again. Here, that's 1, 5, 7, 9, so that 6 can only be here, and that's a 2. But I use heavy pencil marking here. That's not so elegant. I agree with that. 1 is not here. This can only be 7, 8, or 9. That can't be 8. 1, 7, 8, 9 here. That's a bit on the ugly side of things. Let's recall that this is 7, 8, or 8, 9. No, 6, 7, or 8, 9. That doesn't say anything. There's a 1 somewhere here. Where should we look? Is it here? Oh, perhaps we should ponder the possibilities here. Something interesting here is that those digits have opposite parity, so that those digits must also have opposite parity. And I should perhaps explain why this is the case. Let's say this is odd. Let's say this is 1. When this plus that is odd, so this plus that is odd, in which case this must be even. And if instead of 1 I had put any odd digits, then the result would be the same. An odd digit would result in an odd sum, which would result in an even digit here. And if I put an even digit here, that's the same. So here I need an odd and an even digit. But in this column, I already have 2, 4, and 6. So there must be an 8 in one of those cells. And because of this 8 goes here. So now the sum is 14. So 3 doesn't work. And this has to be 5 or 7. So we have either a double 5 or 5 here and 9 there. And this now is 1, 5, 7, or 9. And that looks a bit ugly, but what we can notice here, and I could have made all of this with colors, is that we have 5 odd digits in this row. And we know that a row contains exactly 5 odd digits, so the remaining cells must contain here even digits. So this is 2 and this is 5, and those are among 4, 6, and 8. But this comes before an 8 because of the column, so this is 6, this is 8, and this is 4. So the difference is 7 after all, and now this must be 9, which removes 9 from quite a number of cells, and we know that there must be a 9 somewhere here. Right, so where should I look next? So the sum here is 8, and the only way to have an 8 on the other diagonal is to have 1 here and 7 there. So let's remove a few more 7s. And now this one makes this a 7, this a 3, that's a 9, that's a 1, that's a 9, that's no more a 9, this must be 9, because of the 5, 7 pair, those are not 9s, that's not a 1, so this is a 9, that's 5, 1, 7, 5, and 7, and this is 5, and we can see that that's really a sum of 14. That's a 5, 9 here, 5 here. That's not 9. That's good progress. Let's move further. This is not 1 or 7, so 1 is here. And this is 8 or 9. Here I need 2, 8 or 9. That's not 8. Here the options are 2, 3, 7, and 9. 9 is not here. 7 is not there. 3 is not here. That's correct. Now all the Mathrax part has been done. The rest is Sudoku. 5 is not here, so this is a 5, 6 pair. And here we have a 7, 8 pair vertically, which means that this is 3 and 4. There's a 4 in this row, so that's 3, that's 4. That's not 3, so I get a 3 here. 2, 7, and 6. I need the 1 somewhere, that's here, that's 2 or 7. And all has been pencil marked, so now I must find something that's Sudoku. I must find a Sudoku trick. So maybe there's just a free candidate somewhere. Yes, that's it. This 5 makes this a 7. That's 5, that's 2, that's 6, 7. 2, 7 and 9, 8 and 2 and 9, and 7 and 9, and 7 and 8, and 5 and 6, and that's it. So this finishes the solve of this puzzle of mine, called Mathrax, and it could be a Mathrax with mystery clues actually, because the standard Mathrax has all the clues explicit. But I found it really, well, a bit more fancy to have some mystery clues in the process. Thanks for watching this video and see you soon on SudoKanard. Hey.